the node rule. The principal concept in the node rule is that the current in is equal to the current out. This is the circuit that's in the wiki already, and I'm just gonna go through how the node rule applies. So here we have a battery, and when you have a battery in a circuit, the current goes from the positive to the negative. So we start our current, and it goes, and it goes, and it goes, and it goes. And it goes right through the resistor to B. So the current in I is the same as the current in B. And this is I1. So over here we have a capacitor. If the switch has been on for a very long time, closed for a very long time, the capacitor will take up all the voltage, so this whole wire will be omitted, and there'll be no current going through at C. So then the current continues from this point here and goes straight through R2 and down and over here. So that means that the point A, B, not C, there's a point right here, D, and E all have the same current. And because we know that, we can now use this in the loop rule, which is this long loop right here. And this is EMF equals the change of potential of R1 plus the change of potential of R2. And those are the two resistors. And then over here, when you see the EMF, you see that there's an I here, and those are both the same thing because of the node rule, in equals out. And then you get your final current is equal to EMF over R1 plus R2. But if the capacitor wasn't there, or if the capacitor wasn't fully charged, like the switch was just closed, this is how the circuit would look with the corresponding currents. So first you have a current coming out here, and it will go, and this is I1. But now you get over here, so then the current splits, because now you don't have the capacitor. So then you have I1 is equal to I2 plus I3, and that's the node rule.